You know, from the camera in your phone to that chatbot you just messed around with, AI is absolutely everywhere. But here's the thing, it didn't just appear out of nowhere. It was a 70-year journey of incredible breakthroughs. So how was the AI that we all use today actually built? Let's dive in and unpack the story of how we created these unbelievably powerful, specialized tools. So, before we get into the weeds, we gotta understand the big picture, the map of where all this is headed. People usually see AI's evolution in three big stages. Right now, today, we are firmly in the era of ANI, which stands for Artificial Narrow Intelligence. The next big step, the one everyone's talking about, is AGI, or General Intelligence. And way out in the future, that's ASI, or Superintelligence. But for us, today, it's all about the foundation, the ANI that's changing our world as we speak. All right, so here's our roadmap. First, we're going to jump in our time machine and go back to when human had to literally write every single rule for an AI by hand. Then we'll hit that revolutionary moment when AI started to learn all on its own. After that, we'll check out the amazing, specialized brains we're building today for things like sight and language. And finally, we'll see how all of this sets the stage for what comes next. Okay, so what exactly is this ANI we keep talking about? The best way to think about it is as a super specialist. It's an AI that can be superhuman at one very specific thing, like being the world's best chess player, or instantly translating a sentence. But here's what's key. It wasn't some single aha moment. It was built piece by piece over decades on three giant pillars. Some really clever math, a massive explosion in computing power, and probably most important, access to just unimaginable amounts of data. So let's start at the very beginning, in an era that feels almost ancient now, a time when AI couldn't learn a single thing by itself. If you wanted an AI to do anything, a person had to sit down and painstakingly write out every single rule. In the early days, this was all just simple if-then logic, kind of like a giant flowchart. You know, if the light is red, then stop. It worked okay for simple puzzles, but that's about it. Then, by the 80s, we got a bit more sophisticated with something called expert systems. The idea was to interview human experts, say a doctor, for months on end, and try to turn all their knowledge into a giant database of rules. This let AI do some really complex stuff, like help diagnose diseases, but it always had a hard limit. An AI could never, ever be smarter than the experts who programmed it. And then, everything changed. Seriously, this is the moment modern AI was truly born. The entire philosophy flipped. Instead of spoon-feeding rules to a machine, people started asking, what if? What if we could build a machine that could figure out the rules for itself? And just like that, the world shifted to machine learning. And this is the absolute key difference. With machine learning, you stop giving the AI instructions. Instead, you just give it data. Tons and tons of data. The AI then uses powerful statistics to find all the important patterns and connections all by itself. In a way, it actually programs itself based on all the examples you show it. So the most common way this happens is through something called supervised learning. It's a simple loop, really. First, you feed the AI tons of labeled examples, say 1,000,000 photos, each one tagged cat. Then step 2, you show it a brand new photo, and it makes a guess. Is that a cat? Step 3 is crucial. A loss function, you can just think of it as an error checker, calculates how wrong the guess was. And finally, step 4, the model uses that error score to automatically tweak its own internal wiring to make a slightly better guess next time. Now, you just repeat that loop millions or even billions of times, and pretty soon you've got an AI that's a world-class cat detector. Now, if we take that idea and turn the dial up to 11, we get deep learning. This is the real engine behind pretty much all the AI you hear about today. It uses these things called neural networks, which are basically complex mathematical systems loosely inspired by the human brain. And here's the absolute magic of it. A deep learning model figures out what's important all on its own. Going back to our cat photos, you don't have to tell it to look for whiskers or pointy ears. It just learns that those features are important for identifying a cat completely automatically. Now, for a long time, these big, deep neural networks were just a cool idea on a whiteboard because nobody knew how to train them. They were just too complicated. The breakthrough, the key that unlocked everything, was an algorithm called backpropagation. The best way to think about it is like this. After the AI makes a guess, backpropagation sends a report card all the way back through every single layer of the network, telling each one exactly how it messed up. Each layer then adjusts itself a tiny bit. It's an elegant mathematical trick that, and this is no exaggeration, made the entire deep learning revolution possible. Okay, so we've got these incredible learning machines. But the real genius of modern AI is that we don't use a one-size-fits-all approach. Nope. Instead, researchers have designed all these different brain architectures, each one custom-built to be absolutely brilliant at one specific job. Let's start with sight. How do you give an AI a pair of eyes? Well, if you want an AI to understand the visual world, you use something called a convolutional neural network, or a CNN for short. This is the bedrock technology that powers everything from the face unlock on your phone to the vision in self-driving cars. So how do these things actually see? It's fascinating. A CNN has these special layers that scan over an image, almost like a detective with a magnifying glass. The very first layer might only be able to see simple things, like straight lines and curves, but the next layer takes those lines and curves and puts them together to see basic shapes. The next layer puts those together to see things like an eye or a nose, until at the very end it can confidently say, "Yup, that's a cat." It builds understanding from the bottom up, which is what makes it so incredibly accurate. All right, so we've given AI eyes. Now let's give it ears and a mouth. To get an AI to understand and generate human language, we need a totally different kind of brain. And today, that brain is almost always the transformer model. Transformers are designed for data that comes in a sequence, like the words in this very sentence. Their absolute game-changing trick is something called the attention mechanism. It lets the model, as it looks at a single word, pay attention to every other word in the sentence and figure out how they're all related. That ability to understand context is what completely revolutionized machine translation. And yes, it's the core engine inside things like ChatGPT. So, last one. What if you don't have a neat data set with all the right answers? What if you want an AI to just figure out how to win a game or discover a totally new strategy on its own? For that, we turn to reinforcement learning, which is all about learning by pure trial and error. The idea is actually pretty simple. You have an agent, that's our AI, and it's in some kind of environment, like a video game. It takes an action, and if it's a good action, it gets a reward, points. If it's a bad action, it gets nothing, or maybe even a penalty. Its one and only goal is to get the highest score possible. It's not told the rules, it's not given a strategy guide, it just discovers what works by trying things out, millions and millions of times. This is exactly how DeepMind's AlphaGo taught itself to become the best Go player in the history of the world. So let's recap. We've built these incredible, specialized AIs that can see, speak, and strategize, a lot of the time way better than any human can. It sounds almost magical, and in many ways it is. But now we have to take a step back, put it all in perspective, and really understand the fundamental limits of the AI we've built so far. And that brings us to the single most important question you can ask about this technology. With all these amazing, superhuman abilities, what's the catch? What can't today's AI do? Because the answer to that question reveals the massive, enormous gap between where we are today and where we might be going. This chart really lays it all out. Just look at the first column for ANI. That's us, right now. At its very essence, it is a statistical pattern recognition machine. It's brilliant, but only inside the little box it was trained in. Look at the flexibility row. It completely fails outside its specialization. Now, the jump to AGI isn't just about being better, it's about being different. It's a leap from recognizing patterns to actual reasoning and adapting to brand new situations. And ASI? Well, that's a whole other level. That's a jump to a kind of self-improving intelligence that we can barely even imagine right now. When you look back at this whole incredible journey, this quote just says it all perfectly. We didn't create an artificial person. We didn't build a consciousness. What we did was take very specific parts of intelligence, like our senses of sight and language, and use a ton of math and computing power to make them inhumanly sharp. And that, right there, is the ultimate takeaway. The AI we have today is not a thinking mind. It's a tool. It's the end result of decades of work to build separate, incredibly powerful, and highly specialized tools. We didn't recreate a brain. We perfected an artificial eye, an artificial mouth, and an artificial strategist. So here we are. We've built tools that can see better than us, write faster than us, and strategize in ways we never could, all in their own narrow lanes. The foundational journey to create these things is, for the most part, done. But that success just brings up the biggest question of all. Now that we've forged these unbelievably powerful tools, what are we going to build with them? Where does this journey take all of us next?